back to Cryptography Part 3. Last part, we taught you how to color code encryptions. So, Alex and Sam want to talk, but Evan always, this is the situation. Evan always will hear everything they say, no matter what, okay? They will hear everything they say. So, even if Alex wants to send something to Sam, Evan will always see it. So the blue line means not directly, and the red line means directly. In the last episode, we taught you a way to color code it. So we have 3 colors, but we're going to transfer those colors to numbers. For example, blue is going to become, that's a little too light. I'm sorry. Blue is going to become 6. Red is going to become 7, and yellow is going to become 2. And as 2 plus 6 plus 7 make 14. 15. I'm sorry. Because 2 and 6 make 8, and 8 and 7 make 15. So, as you see, Alex sends something to Sam directly. But of course, Evan will always hear it. I'm gonna say when this is not happening, but if I don't disclose this person, like saying, so blue is non-directly, blue is just finding it, hacking into it, the system, and red lines are are directly sending it. If I say this slide doesn't count, then that basically means this slide doesn't count. So Alex gets a private key, and he also has a public key. The public key everyone has, Sam and Evan. And the private key Alex only has. He can't send it to Sam because then Evan's going to hear it. It's not going to be private anymore. Sam also has a private key. So they both have a private key, and they both have a public key. As you see, there isn't necessarily someone doesn't own the public key. The public key is public to everyone. The private key someone always owns. Sam can't send the public key to Alex, nor can Alex send it to Sam because Evan is always gonna hear it. So Alex's private key over here and the public key basically 6 and 2 make 8. This red line doesn't mean direct messages, it's just a color. So basically, as you see, 2 and 6 make 8, so you're going to see these 2 combine. As you see, they've become 8, that they've become green. And Alex sends the green to everyone, so it becomes a new public key. So now, Evan has the private key. Evan also has Alex's public key, the public key plus Alex's private key. Sam has both those things and his own private key. Alex also has his own private key and Evan and the public key and his private key plus his public key. So now Sam mixes his private key with the public key, which makes 7 plus 6 makes 13. This blue does not mean non-direct messages. So he sends 13 to everyone. So now Evan now has the public key. That's a little too dark. Yeah, the public key, and he has Alex's public key, Alex's private key plus the public key, and Sam's private key plus the public key. And Alex has his own private key, the public key, it's not there. Sam's private key and public key, and the public key. Same for Sam, but instead of having Alex's private key, he has his own private key. as you see. And 13 plus 2, look, so basically Sam's private key plus Alex's private key and public key make 15, and Alex's private key and Sam's private key and public key make 15. So they both make 15. Now I'm gonna be the reason for this is they both equal the same thing. So I'm gonna be explaining why this isn't a good strategy and Evan could easily decrypt this, and why in the next episode we're going to teach you a better mathematical solution. So Evan knows this is a public key. And Evan knows this was sent by Alex and this was sent by Sam. That's a little dark. So Evan knows this is the private key. Evan knows this is sent by Alex and this is sent by Sam. So Evan knows this is Alex's private key plus the public key, which is 6. And if that equals 8, simple algebra, that means Alex's private key is 2. Same thing around. This is Sam's private key plus the public key, which is 6, which equals 13, which now Evan knows that Sam's private key is 8. So with simple algebra, Evan can find the answer. And you may be asking, why is this Sam's private key important? Well, basically, Sam's private key is 7, right? Evan could add 7 to 8. 7 with 8 over here. I'm sorry if this is a little messy. With 8, oh, that's with 8 over here, okay? And the 7 over here that he got from Sam's public key with 8 over here. And remember, these are not direct messages. This thing has no direct messages or non-direct messages. And this 8 over here that he found could be plus with the the 2 over here, Alex's private number key, could be added with the 13. They both make 15. So there's a pretty simple way of finding 15. In the next episode, we're going to be teaching you a little bit more complicated way. So Evan can't decrypt it as easy. We have to find a way that when it's easy to encrypt, but it's very difficult to decrypt. So easy. This is a little mix up. I'm sorry.